Okay, PreCal, this is our last test of the semester. And so we are doing test 3.3 review, and we are converting logs to exponents and exponents to logs. So this is very easily done by keeping the base while the others change place. So if you remember, keep the base, the others change place. It's very easy to do. So in this one we have a log base 5 of 25 equals 3. So we keep the base of 5 and the others change place. So my 3 and my 125 change place, and I end up with 5 to the third power equals 125. And these two expressions are equivalent. All right, B, keep the base, the others change place. Here I have an exponential and I need to convert it to a log. So I write log base 8, the others change place, of 64 equals 2. Log base 8 of 64 equals 2. All right, the third one, C, we're going to have log base 2 of 32 equals 5. That's going to be keep the base. The others change place, so the 5 and the 32 change place, and we have 2 to the 5th power equals 32. Okay, on the next problem, we expand or condense the following logarithmic equations. And so here we're going to expand this log equation by rewriting it as log Okay, so this will be log base 3 of u to the 6th over v squared. So we need to go ahead and take u to the 3rd over v to the 2nd power and rewrite that, which is what I've done here. Now we're ready to expand our log. We have log base 3 of u to the 6th minus log base 3 of v squared. Well, we still need to move these exponents over to the front of the log. That's the last step. So we're going to move it over 6 log base 3 of u minus 2 log base 3 of v. And that's it. And now it's expanded. All right, for the next problem, we're condensing this natural log into one log. So let's rewrite the first part of our equation. So we're going to write ln of z plus, and I'm going to rewrite this ln x to the 3rd power, and then ln y squared. So I'm moving these numbers here. These are actually exponents, and I'm moving them back to the front, or as the exponent to the variable. Now I'm going to combine my ln's together, all as one. So this is condensing ln z x to the 3rd y squared, and that's it. All right, last problem, this is a different problem. This is solving, so let me rewrite this. 2 to the x equals 5. Now here, to solve this is really easy. All we're going to do is convert that to a log so that we can find x. So we are keeping the base, the others change place, and I can put log base 2 of 5 in my calculator, and when I do, I get x equals 3.3219. All right, last problem on this page. We are solving for x again, and this time we have 2 log expressions, each on each side of the equal sign. And since these are both isolated, I have log base 4 of something equals log base 4 of something. Since these are equal to each other, and since these logs are isolated, I can eliminate them. So I'm going to cancel them out. And I'm just going to solve for what's left. So 3x minus 4 equals 2x plus 5. Subtract 2x from both sides, I get x. Add 4 to both sides, and I get 9. X equals 9. That's it. All right, so for problem number 5, we have 4 with a base e to the 3x minus 3 equals 2, and we are trying to solve for x. So the first thing we need to do is add 3 to both sides, and we get 4 base e to the 3x equals 5. Then we divide by 4, and we get e to the 3x equals 5/4. And now I'm going to do my switcheroo. I'm going to change my e to an ln, and I'm going to switch. So ln of 5/4 equals 3x. Now all I need to do is divide by 3. So I'm going to divide both sides by 3, and I have ln of 5/4, all of that divided by 3 equals x. And when I put that in my calculator, I get 0.6694. So x equals 0.6694. All right, so problem number 6 should look familiar. This is p to the 5/3 to the negative 1/5 times p to the 6th. Okay, so the first thing we're going to do is take care of this p to the 5/3 to the negative 1/5. So we end up with p to the negative 5/15. And you can reduce that if you want to, but it's really not necessary. The calculator is going to do that for you anyway. So now what we're going to do is we're going to add, since this is a p with an exponent times another p with an exponent, the p is the base. So all I need to do is add these exponents. So I have negative 5/15 plus 6. And what that gives me then is p to the 17/3. Now when you're multiplying all these fractions together or adding fractions to whole numbers, you can do this in your calculator and it will automatically give you the fraction that you need already simplified. All right, in the next problem we are doing something called rationalizing the denominator. We need to multiply the numerator and denominator only by the root 5. We don't need to do the 4, just the root 5. Okay? And so now in the numerator, when we multiply across, we get 9√5. And in the denominator, we get 4 times 5. Okay, because root 5 times root 5 is 5. That's why we do that. So we get a whole number in the denominator. So now we have our final answer is 9√5/20. Now, if I could reduce that, I would, but I can't, so I'm going to leave it like that. Next problem. All right, so the resolution on my my problems here on my video is, they're not very clear. However, I have this expression in here inside the parentheses, but this very last exponent that it's raised to the 0 power. And we know that anything raised to the 0 power is 1. And the next problem we have, and I'm going to rewrite this because it's not clear, negative 2x to the negative 1/3, all of that squared. Okay, well we have to take each one of these parts separate. So we're going to do the negative 2 separate from the x to the negative 3. So negative 2 squared is just 4. Negative 2 times negative 2 is just 4. X to the negative 3, however, squared is going to be x to the negative 6. Well, I can't have my answer written with a negative exponent, so I'm going to have to put that x to the negative 6 into the denominator, making that x to the positive 6. So my final answer is going to be 4/x to the 6th power, just like that, in the denominator, and that's the final answer. Okay, for question number 9, I've rewritten the problem so we can read it. We have 4 to the 10th times 4 to the negative 2 over 4 to the 5th. All right, for the first thing I'm going to do is simplify the numerator. So 4 to the 10th times 4 to the negative 2 is just 4 to the 8th power. So I just add these exponents together, I get an 8. And then in the denominator, I still have 4 to the 5th. Now, since this is dividing, that means I'm going to subtract my exponents. So my final answer is going to be 4 to the 3rd. And that's it. All right, so problems 10 and 11 are word problems. Problem 10 says, Maria invests $1,050 in a retirement account with a fixed annual interest rate of 7%, compounded monthly. What will be the account balance after 6 years? All right, so let me go ahead and expand this screen and make this a little bit bigger. All right, so for this problem, I'm using this formula. This is our compounding interest formula. And since our interest is being compounded monthly, then my n is going to equal 12. So I'm going to put all my numbers in, and I get 1,050 times 1 plus the interest rate in decimal form is 0.07 divided by 12, the number of months, to the 12 times the number of years, to the 12 times 7. I put that in my calculator and I get $1,711.49. All right, this will be the last problem. Problem number 11. It says Nick invests $2,115 in a savings account with a fixed annual interest rate of 2% compounded continuously. What will the account balance be after 12 years? All right, for this one, we're going to be using the principal with the base e to the RT. This is our compounding interest equation or interest formula. So we're going to put in our P, 2115. We're going to use the base e in our calculator. It automatically gives us a box to put our R times T in. R is the interest rate, which was 0.02. Make sure you put your interest rate in decimal form, times, and then the number of years, which is 12. This should be all in the same little box. Okay, so if that's not together in the box, then you're going to get the wrong answer. So just make sure that's together. I don't know why this 2 is in here. Okay, so then we put that in the calculator and we get $2,739.54. And that's it. Good luck on your last test, and hopefully you all be exempt from your final exam, and we'll see what happens. But I wish you lots of luck, and I hope you do just as well on this test as you did on the last one. Good luck, Longhorns.